no, 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 that, the,
So, you probably had a hard time understanding my introduction. What I said was, hello, my name is Jonathan Van Steenberg. I'm a student at Florida State University in Panama City. This presentation describes a project I am working on with a group of students to develop a more robust adaptive computer user interface for people with disabilities like me. I did the voiceover on the first slide to make a point that I will come back to later. For the rest of my portion of this presentation, I will use text-to-speech to communicate. I will discuss the problem my group and I are trying to address with this project. I will also go over some of the research we did on platforms, frameworks, and programming languages that are available for use on this project. Next, Lee will discuss the security of our system, then Carrie will talk about the predictive text feature, and finally Alex will go over the various hardware interfaces and non-functional requirements for this project.
All software users get frustrated with software that makes it hard to get even the simplest task accomplished. There are many people with a wide variety of disabilities that have a need to access computers and other devices. In today's world, computers have become an essential component of day-to-day life. People with disabilities face a true dilemma. They can have a very difficult time using computers and software, while at the same time, computer technology is even more important to them than others because it helps them compensate for their disability. For instance, you heard my impaired speech at the beginning of this presentation, but I can use software technology to communicate, which helps, but there are other issues. As you can see in the video, I can't use a mouse. I can't use a keyboard either. The good news is that people with impaired muscle control can use adaptive devices and software to overcome issues like this to access computers. However, the trade-off is that the process of using these tools is typically very, very, very slow. I would show you a video of how I do email, using a program called the Grid 2, but we don't have that much time. Another frequently occurring issue arises with people that have impaired sight. They use adaptive tools like screen readers to get information that would otherwise be inaccessible to them. In fact, there are almost as many variations on adaptive software requirements as there are people with disabilities. Our group is not the first to investigate this area. In the paper, An Environment for Designing and Sharing Adaptation Rules for Accessible Applications, the authors talk about the dimensions of the design space of user interfaces devoted to people with disabilities. As you can see in this graphic, the authors identified 35 combinations of rules attributes based on the user disability, abstraction level, granularity level, and adaptation type. Because of the complexity of the problem space and the limited completion time for the project, we will limit the scope of the project to address mouse and keyboard accessibility and word prediction for people with motor and dexterity impairments. There are many adaptive systems for use that address these types of issues. They are either free or available on the commercial market, often at significant cost. While each has its strengths, each typically has some limiting factor with regard to functionality or other constraints such as operating system requirements. The objective of this project is to develop an adaptive interface that is flexible in that it is easy to install and configure. It can be easily tailored to work with hardware for people with specific disabilities and tailored to specific user needs. In addition, it would be open, in that it will operate on multiple operating systems and the code will be available for others to use. The platform is the environment in which the software will execute. In the case of adaptive interfaces, the hardware component of the platform will consist of a desktop, laptop, tablet, or other mobile device. To a large extent, the hardware component dictates the operating system of the platform. Operating systems for this effort would likely be Microsoft Windows, Mac OS, or Android. Multiple operating systems present some issues with regards to developing a cross-platform application, which is further complicated by the need for a database to facilitate word prediction. In addition, many if not most of this user community will need some sort of alternative hardware interface such as switches, camera, or enhanced keyboards to access the application. This drives a need for robust support for these types of devices which typically use USB and Bluetooth technology. Further, many in this user community have a need for devices with sufficient screen size for them to see the output. Research shows we need what is termed a middleware integration framework, which consists of a set of standards and associated object classes that support component communication and information exchange. Microsoft's .NET and Enterprise Java Beans are in this category. In addition, there are others such as Rails and Django. All these frameworks follow a model view controller design pattern that was traditionally used for desktop graphical user interfaces, although this architecture has become popular for designing web applications as well. Django and Rails are both frameworks for web applications, so they did not appear to be a good solution for this project. .NET would seem the obvious choice, however. The issues with .NET's cross-platform operation limits future development for mobile platforms. JavaBeans gives us a cross-platform capability, so we will work with JavaBeans, but will default to .NET if JavaBeans is not robust enough for our application.
We considered a number of languages as candidates for this application including C, C++, C#, J#, Java, Ruby, and Python. However, choosing JavaBeans as the framework drives us to Java as the programming language for this effort. If we find that JavaBeans and Java are not robust enough for this application, we will go to the .NET framework and select C# as the programming language, primarily because of the team's familiarity with C++, which is similar to C#, and the fact that using C# is more compatible in the .NET environment. This concludes the user interface portion of our presentation. Next, we will discuss the security concerns for our system.
Hello, my name is Lee, and I will be covering the security portion of the adaptive computer program. I will be going over the different platforms we have chosen for our program and their risk, the frameworks we will be using, and some security considerations. Across the board, for any of the platforms, the simplest thing we can do is to allow the application to run offline, independent of the internet. Our primary platforms are desktops and laptops on Windows because they are the most widely used. However, its greatest strength is also its greatest weakness. Since it's so widely used, it also has the most vulnerabilities. So with it, because Mac and Linux are not as widely used, they are not as vulnerable. Today it has been increasingly easier to obtain a smartphone. It offers convenience, and for the impaired, a mobile lifeline. People place a great deal of their lives on their phones, so security is important. The two biggest market players are Android and iOS. iOS is well regulated, just like Mac. However, Android, not so much. Users should be able to utilize the camera and Mac without being insecurely monitored. Like PCs, preliminary security measures are up to the user. The first framework I would like to talk about is the Open Software Assurance Maturity Model. This model will help us develop and plan with a security focus. It's fast and incremental, so fast most activities can be done in under an hour. It utilizes activities such as code review and pen testing. Basically, a score of 0 to 3 is given, and if the score is too low to be acceptable, then we go back. Since this framework is not a programming framework, it can be used in conjunction with one. The programming framework we have chosen is the Oracle Software Security Assurance Model. Java Standard Edition provides a great set of tools, such as the sandbox, that will allow us to test the program in an isolated environment. The model is focused on reducing data corruption and vulnerabilities. Since Java is a high-level language, productivity is increased. My first consideration is to have a layered architecture. We don't have a critical system, nor is there much to protect with authentication. However, our word bank is in a database, which we can place on the bottom layer, and obviously the interface on the top. The next one Jonathan brought up. For the current program he uses, every time he executes, the user account control pops up, and he has to have someone else click it. A possible workaround is to have the program upon installation. Create a shortcut through the task scheduler with highest level permissions possible. As time goes on, we want our program to be easier to use and have increased functionality. Patches will allow us to do this, so we want to develop with maintainability and refactoring in mind. If there is an issue with a patch, users can download an older version from the archives on our website. Another way to add functionality is to have plugins. There is one issue with this, which is third-party developers may have obsolete code with their plugins. A possible solution is to have a regulated marketplace, which will allow users to review apps and add their own. This concludes the security portion of our presentation. Next, we will discuss the predictive text feature.
Hi, my name is Carrie Johnson, and during this portion of the presentation, I will show you a demonstration of one of the adaptive computer user interfaces currently on the market. I will discuss how we will improve upon the predictive text systems currently available in these interfaces. I will explain the differences in the databases we examined for this project, and I will present our final database selection. Here is Jonathan using his current system to write an email. His system is called the Grid 2. If you look at the keyboard, you can see a list of words directly to the left of the letters. These words are the ones the Grid's predictive text think are the most likely to be used. As you can see, this system only has 4 options. Having these words available saves a lot of time. So one of the goals of our project is to increase the number and the accuracy of the words provided by the predictive text. One way we intend to improve the accuracy of the words provided is to allow the user to select a context before they begin typing. There will be several context choices, including family, friends, school, and business. Assume our user has selected the business context. Our predictive text will then favor words that are more likely to be used in a business setting. The user can input their own top choices or wait because the system will learn their preferences over time. In addition to providing words based on the context, we will allow the user to select from full sentences based on the context as well. The user can again select their own favorites, or the system will eventually learn these too. In a given context, once a phrase is selected, the sentences that are most likely to follow the selected phrase in the course of a normal conversation in that context will be presented to the user. We will store our single words and our completed sentences in a database. 3 types of databases were studied for this project. Those studied were SQL Server, Sybase, and Oracle. While all of the options have advantages and disadvantages, Oracle works best for this project. There are a few reasons why Oracle works better for this system. For one, SQL Server is not compatible with Java, but Oracle is. Also, SQL Server only works on Windows. Sybase could be an option because it has better security. Another advantage for Sybase is that it is usually cheaper than Oracle. The major disadvantage of Sybase is that it is primarily used with Linux. It is also compatible with far fewer languages than Oracle. The main advantage Oracle has over its competitors is its ability to function on a multitude of platforms. It also is compatible with Java and is widely used. This concludes the predictive text portion of our presentation. Next, we will go over the hardware interfaces and non-functional requirements of our system.
Hello, my name is Alexander Morrison. My portion of the presentation will cover the hardware interfaces and non-functional requirements of our adaptive computer system. I will discuss integrating different hardware with our system, the types of hardware that might be used with our system, and the various requirements for our system. Integration. The good news for our project is that integrations can be very easy. Many of the existing interface hardware come with their own software that takes direct control of keyboard and mouse. And most of it's USB compatible, so all we have to do is just make sure that our project doesn't interfere with the existing drivers and software. The 3 types of devices considered for our project will be switch, eye tracking, and head tracking. We'll discuss the pros and cons of each of these. The switch is the simplest of all of the input hardware. Now, while it is slow to use, it is the most versatile. It can be used with almost any electronic device, computers, tablets, phones, anything, as shown in the picture. The user, by use of 1 or 2 buttons, depending on the system, can cycle through timed menus and other types of commands in order to select and do whatever it is they need to do. Eye tracking software is probably the best of the input hardware devices that our system can use. By its own basic design, it's meant for use with a keyboard and other similar types of interfaces. A lot of its specifications, in the case of eye gaze, will probably inform a lot of our user interface design, that being the size of buttons and the spacing between them. And as I mentioned, since it's meant to work with existing keyboard software that comes with the eye tracking hardware and software, this really is a bonus for our project, as it is basically built for exactly what we're trying to do. Head tracking is an outside third option. Originally meant for VR and gaming uses, it probably won't work well on its own, but combined with a switch device might be one of the faster methods in which to use our system. The durability of our software largely consists of things the software must not do. It must not freeze or lock up beyond reasonable limits during use. It must not freeze or lock up the device it is installed on. It mustn't interfere with other system functions. It must not lock up input devices. And conversely, it must not lock up due to the input devices. This part will be a security concern, as we need to check the input to ensure that proper data types are being passed. Ethical concerns will be very important to our system. Our program is going to handle pretty much every interaction that the user has with their computer, tablet, or phone. This can include inputting usernames, passwords, social security numbers, and other private information, possibly handling banking and medical info. Now, being able to turn off the cookies in terms of maybe the last 10 minutes of work, the last hour, the last several inputs, or even just being able to turn off the word prediction system entirely and quickly is going to be very important, because the user may not want the system to log and record what they've entered, what they've selected, and what options have been presented to them. Efficiency. Simply put, the program must not consume too great a share of system resources. Word prediction is a simple enough process that this shouldn't be a concern for us. The options to clear history, delete seldom used prediction paths, maybe a one-off search for some item, the user just doesn't care for it to show up again. Also, automated processes such as RAM allocation clearing should be a very good thing to improve efficiency. After all, we want the user to be able to work a full 8-hour day without incident.
This presentation covered our Adaptive Computer Interface project. We discussed the difficulties in using computers faced by people with disabilities and how our system can address those concerns. We discussed the language, framework, and platform we intend to use. We also discussed the user interface, and we addressed the security concerns of the system. The predictive text feature was discussed, as were the hardware interfaces and the non-functional requirements of our system. Thank you for watching our presentation.